Hi guys, welcome to Learning Hub. Today we will learn about integer representation, the very important concept from computer architecture and organization. So let's start. So here, integer representation is divided into two forms, that is unsigned integer representation and signed integer representation. Now what is unsigned integer representation? Unsigned means nothing but the name itself tells us that it is having no signs, that is the values of the unsigned numbers varies from 0 to positive infinity. Okay, and in signed integer representation the values of the number or the value varies from minus infinity to positive infinity, means both positive as well as negative numbers are present in signed integer representation. Further, signed integer representation is divided into three types, that is signed magnitude, one's complement and two's complement. We will elaborate these three concepts further. Next, unsigned integer. Now what is unsigned integer? As I said previously, unsigned means nothing but integer without sign, and the second is its range is between 0 and positive infinity. Okay, so now here is one table representing the number of bits according to its range in unsigned integer. Okay, so for the 8-bit number the range is 0 to 255, and for the 16 bits number the range is 0 to 65,535. Here there is an example given of the unsigned integer representation, that is we have to represent the positive 5 in an 8-bit number representation. So how we will represent this? So first of all, change the given decimal number into the binary form. Now what is a binary of 5? That is 101. Now what we have to do is we have to make this 3-bit number as an 8-bit number. So what we'll do is we have to just add 5 zeros followed by 101. See here, make it an 8-bit number, that is 5 is equal to 5 times 0, 101. Why we have to do such things? To make it as an 8-bit number. Okay, this is nothing but unsigned integer representation. Next is signed magnitude representation. Now in this representation the MSB, that is most significant bit, is used as a sign bit to indicate the sign of the integer. First of all, I'll tell you that what is MSB and what is LSB. See here, consider this value. Here the first digit is known as the MSB, that is most significant bit, and the last digit is known as LSB, that is least significant bit. Okay, the remaining 7 bits represent the magnitude, that is absolute value. See here, in the signed magnitude representation the first digit is represented as MSB, that is most significant bit, and the rest all 7 bits are represented as absolute value, or we can also say it as a magnitude. Okay, in the signed magnitude both positive as well as the negative values are used, as I said previously. Okay, so for positive numbers the MSB is 0, and for the negative numbers the MSB is 1. See here, if the number is given positive and we have to give the MSB, then it is 0 for the positive number. Okay, now for the positive 5 the MSB will be 0, but for the negative 5 the MSB will be 1. We'll see the example. In the binary form it can be written as, means the 5 in the binary is written as 101. Now we have to write it as an 8-bit representation. Okay, so what we'll do first, we will give 101, we'll write it as it is. Okay, followed by that we will give 4 zeros. Okay, so now how many digits we will get? We will get 7 digits, that is 1, 2, 3, 4, 5, 6, 7. But we have to form an 8-bit representation. Now what we'll do is we'll give the MSB, which will be totally dependent on this sign. Now here we are finding the binary form of positive 5. So what will be the MSB of positive 5? It will be 0. Okay, so what we have done is we have written 101 as it is, followed by that we have given 4 zeros. Then we got the absolute value, and again we given 10, that is our MSB. Similarly for negative 5, the binary form of positive 5 will remain as it is, that is 101. But in the 8-bit representation what we'll do is we'll give 101, followed by that we will give 4 zeros. We will get an absolute value, and at the MSB place we will give 1 because the value is negative. So this is nothing but the signed magnitude representation. Next is one's complement. Now what is one's complement? It uses the MSB as the signed magnitude. Means, as I said previously, while teaching the sign magnitude that MSB indicates the sign of the bit. Okay. For positive numbers, all the bits remains same. In the ones complement, whenever we use a positive number, all the 8 bits remains same, no change. But when we use the negative numbers, then it flips all the bits of the corresponding positive number. Now we will see this with the help of an example, that is for 7, for positive 7. What is a binary form of 7? That is 111. Now, how we will represent it as an 8-bit representation? What we'll do is, for positive 7, we will write 111 as it is. Followed by that, we will give 4 zeros. We will get an 7-digit number, 7-bit number, okay. And for the MSB place, we will give 0. Why 0? Because the number is positive. अब कुछ नहीं करना. Now what we have to do to find the ones complement of negative 7? We have to just flip the numbers of the corresponding positive number. Now we have got the corresponding positive of 7, that is 0, 0, 0, 0, 0, 1, 1, 1. What we have to do to find negative 7? Just we have to flip all the digits. What we have to do is 0 को 1 करना है, 1 को 0 करना है. We will get the answer of -7 in the binary form. Okay. As an 8-bit representation. This is nothing but the ones complement. Now the next part is 2's complement. Now what is 2's complement? It uses MSB to represent the sign bit. Okay. As previously we saw in ones complement, also in the sign magnitude, that MSB is used to represent the sign bit. Okay. For positive numbers, the representation is same as in the sign magnitude and ones complement. There is no change in steps to remove the positive numbers 2's complement. Okay, it is similar as in sign magnitude and as in ones complement. Okay, next is for negative numbers, first perform the ones complement and then add 1 at the LSB. Means for the positive number, see here, for the binary of 7 is 111. So followed by that we have given 4 zeros and the sign bit is positive, so we'll give here 0. Okay, then we will get in 8-bit representation, similar as in sign magnitude and as in ones complement. But in the 2's complement, for the negative numbers, first we have to remove the ones complement. Okay, and उसके बाद हमें क्या करना है? We have to add 1 at the LSB. Means, see here, first remove ones complement by inverting all the bits of the positive number. What is our positive number? 5 times 0, 1, 1, 1. Okay, then what we'll get, the inverted bits is 1, 1, 1, 1, 1, 0, 0, 0. Okay, just we have to flip 0 to 1 and 1 to 0. We will get 1's complement of 7. Now to find the 2's complement, we have to just add 1 at the LSB position. So now here is our 1's complement. Then we have to add 1 at the LSB, that is least significant bit. So what we'll get is 0 plus 1 is 1. 0 as it is, here 0 as it is, 1, 1, 1, 1, 1. So this is the value, that this is the answer for 2's complement of -7. So see here what we have learnt in, for 1's complement, the positive number remains same as in sign magnitude. Okay, we have to just remove its binary form and convert it into an 8-bit representation. Okay, but in the ones complement, to remove the negative number, what we have to do is we have to flip all the digits of positive number. And in 2's complement, what we have to do is we have to flip all the numbers of the positive element. That is, we have to perform first ones complement and again then we have to add 1 at the LSB position. Then we will get the value from 2's complement. Okay, thank you.